Okay guys, so we're on the World of Graphics book again, and we're looking at this question 5. So the orthographic views of an object are shown below. Create an isometric drawing of the object. Okay, so the first thing we want to do is to draw the orthographic views. So what I'm going to do is I'm going to go over my sheet and I'm going to set up my border. So we're going to call this isometric drawing number 7, our name on the top right and the date on the top left. So as we look at it from the elevation, the height here is 25 plus 40, so it's going to be 65 tall, and the width is going to be 65 plus 15 plus 15 plus 25, so 120 wide. Okay, so 65 tall, 120 wide. So what I'll do is, it's going to be 65 tall, so I'm going to leave a 15mm gap between the bottom of the border here and the top of the shape. So I'm going to measure down 80mm. And I'm going to draw a line about halfway across the page. Okay, and this will be our XY line in just a couple of minutes. But before I do that, I want to draw the overall width of the shape. So the width of the shape is going to be 120. So I'm going to measure in 10 from my border on the right, and then measure in 120. Okay, so from this point to this point is 120mm. Overall height of my shape is going to be 65, as we spoke about. So I'm going to start with a construction line here and measure up that construction line 65mm to get this point. Draw a construction line straight up from this point over here to the right, 120mm away from that, and join them together then with a horizontal line. Okay, so this rectangle that I've created here, that's 65 tall, 120 wide, is going to, the elevation is going to fit exactly into that. Now, 20mm below that, so I'm going to measure 20mm below the XY line, and I'm going to draw a horizontal line, like so. And I'm going to drop down the width that I've got here. So this is 120 wide. And I'm going to drop down that width, so that 120 wide is going to be dropped vertically down. Okay, and the width of my plan and the width of my elevation are always going to be the same. Okay, so the width of the elevation and plan don't change. And we see here that the depth of the shape now, as we look at it from the plan, is going to be 20 plus 15 is 35, plus 50 is going to give us 85. It's going to be 100. Okay, so 100 altogether. So back to my drawing here again, and from this line that I've drawn, and as I said, the width of the plan doesn't change. So if you look at the shape here, it's I think we said 120 wide. It's going to be 120 wide in the plan as well. Okay, and from this line that we've drawn, we're going to measure down 100mm. Going to get me this point here. Okay, so what I'm after doing there now is drawing a 120 wide rectangle and 100mm tall rectangle, and my plan is going to fit perfectly into that. Okay, last thing I want to do is find the end view. So if there's 20mm left between the elevation and the plan, if I project a line up here at 45 degrees, that will mean that that distance between where that cuts the XY line and the edge of my elevation is also 20. So that's a way of transferring that measurement up into the end view. Okay, so from that point I'm going to draw a line vertically up, and the height of the shape doesn't change now between the elevation and the end view, so I can transfer this distance or this measurement across here. And I want to do the same with the bottom of the plan, so the very bottom of the plan, transfer it up until it hits the XY line, and this is why I didn't write XY on the XY line just yet. So I can continue this XY line out like this, and I can label that XY line now because I know exactly where it's meant to finish. X, Y, and I can transfer that height up now and continue this height all the way across until I hit that line. Okay, and what I've done here now is I've drawn a rectangle that's the same height as the elevation and the same height here as the plan, so the depth of the shape, and that'll give me the end view here. Okay, so the end view is going to fit into this, the elevation is going to fit into this, and the plan is going to fit into that. Okay, so we're going to start now by drawing the elevation and what we know of the elevation. So if we measure up 5 and 20, and we'll get our heights first, and then we'll measure in 40 to get this measurement here, and then up at 45 from the very corner to get this measurement here. So I'm going to start actually by measuring up 5 mil, and 20 above that, so up 25 mil. Okay, I'll draw 2 construction lines like that, and I can actually transfer them over to the to the end view now at this point as well. Okay, so I've measured up 5 and 20. From this bottom right hand corner of the elevation, I can measure up at 45 degrees, and I can do that with a firm line up until it hits the line 25 mil above, just there. I can bring that point now all the way over to the edge, which is just here. Bring it vertically down, and that is the base of that elevation. The next thing I can do is I can measure in 40 here, because it's a radius 40 circle, and draw a line through my end view, or my elevation and my plan, like so, and that will give me the center point of that circle right here. So I can set my compass now to radius 40, which is out to the edge of the elevation, and draw in that arc. So that arc is a semicircle and it has a radius of 40. Perfect, so that's my elevation now drawn. But there's a couple of things I'm missing here. I also have hidden detail. Now, from the dimensions that are given here, I can't do that hidden detail just yet. I'd have to go down and look at the plan. So if I went down to the plan, I'd see that if I measure in 15, I get this line, and directly above that line is this hidden detail line. Okay, so that's telling me that this rectangular shape here that's 65 wide by 50 tall is actually a cutout. Okay, so it's been cut out of that shape. So I can go down now to my elevation, and I have to measure in 15 mil here. And I can draw a vertical line down through my elevation and my plan, and I can now draw in my hidden detail. Okay, so that's the hidden detail drawn in the elevation, and that's my elevation finished. So I can move down to my plan now. And what I want to do is measure out all of these depths first. So 20, 15, 50 and 15. So measuring down 20, 15, 50, and I should be left over with 15, which I am. And I can just draw them with a construction line across like this. And all I'm doing here is I'm about to draw a grid. And once I have my grid drawn, it's actually very easy to join the shape together. So if I get my widths now, it's going to be 15, 65, 15, 25. So 15 is already drawn in. 65 plus 15, and I'll be left over with 25. So I can just transfer them straight up now. Like so. And I have a nice grid drawn here that I can start drawing my plan into. Now if we look at the shape, the whole outside is going to be a firm line. So I can draw that now straight away. All of the outside is a firm line. Okay, and I'm going to work now from the back here and move to the front like this, just when I'm taking my shapes, just so I can be looking at the question, go over to my sheet and look back then again. So I see here that I have to come forward 20 and across 80 mil. Okay, 80 mil because this is a radius 40, so from here to here is going to be 40, and from here to here is going to be 40 again, so 80 altogether. So 20 forward is going to be this point here. And I stop at the measurement right under here. So if you look at that, the measurement right under it is just here, and I can transfer that up now. Okay, so I actually have all my measurements done already. It's just a matter of knowing where they are. So the next thing I'm going to draw is this 50 by 65 rectangle. Okay, 50 by 65 rectangle, and the last thing that we see here is just a straight line all the way down here, and that would reflect this cut angle here as well. So from that point here is going to be dropped vertically down to get that. Okay, and the final thing now to do is the end view. So if we go back here and look at the end view, we have no dimensions given here, which means that all the dimensions that were given over here have to be brought over to the end view. So what I'm going to do is take this 20, 15, 50 and 15 and project them up at 45 degrees. So these measurements here on our plan are going to be projected up at 45 degrees. So this point will be the first I'll take. Okay, and once they hit the XY line, we're projecting it vertically up. Okay, so it's only at 45 degrees until it hits the XY line, and then we'll be bringing it vertically up. Okay, and we'll see that we've actually made a grid here again. And from that grid, we should be easily able to draw the end view. Okay, so once I'm finished that, I'm going to label this end view, elevation and plan. So make sure that you label your views at the end. Okay, next thing we're going to move on to is sketching that. So it's quite a difficult shape to sketch. We're going to try to sketch it up here. We're not going to try to go below the XY line just because we want plenty of space down here to try to draw that in isometric. So what I'm going to do is I'm going to start with my crow's foot. And I'm going to try to keep this fairly small. And I'm going to draw the base to start. So I'm thinking that I'm going to forget about the cut taken out of the base. I'm going to forget about the slant. And I'm going to forget about this curved surface here as well. To start, I'm just going to try to draw a base fairly in proportion to what this base is. So close to a square. And extruded about 1/3 of its height. So starting with my crow's foot, a line up at 30 degrees to the left, a line at 30 degrees to the right, and all my lines are going to be either parallel with one of them lines. Okay, so that's the base before we've even done anything. Next thing I'm going to do is take the 45-degree cut. So the 45-degree cut in my isometric is just going to look like this. Next thing I want to do is to take this cut out of it. And that cut doesn't actually go all the way through the shape. So I'm just going to come down here a small bit and draw it in like that. So it doesn't actually go all the way in through the bottom of the shape. And the last thing I want to do is to draw that curve. So the curve then is going to look like this here. It's going to be in line with this line here. So it's going to go vertically up. And curve like that. Okay, and what I might do then is just rub out my few construction lines. And just go over that with firm lines. Okay, so that's just a nice rough freehand sketch of that shape, what it's going to look like. So the last thing we need to do is draw that in isometric. So we're going to grab our 30/60 set square, and I'm going to start with a line coming down here at 30 degrees, a line going up here at 30 degrees, and a line going vertically up. Okay, so that's our axis, and we want to start making a few measurements. So I'm going to draw it the same way I have sketched out. So this cut surface at 45 degrees, how long is that going to be? So where will we find that dimension? We'll find it just here, over in the plan. So I know that that is meant to be 100 mil. So I'm going to take that dimension and I'm going to draw it in here, 100 mil. And just indicate it with a mark on my line. Next one is this surface going back here, and that would be from the pointy part of the cut surface all the way to the back of the shape. So we can see that that's this dimension here, and we know that that's meant to be 120 mil. So I can mark that one in as well, 120. And I'm going to start by drawing the base, just like what I did here. I'm going to draw the base, then I'm going to make my cuts out of it. And to draw the base, I need to know how high up that goes, and we know that that's meant to be 25 mil, so 25 mil up. Okay, and I can think about now trying to draw that base. So I'm going to start by drawing it with construction lines, and then I'll go over it with firm lines. So from the height here up 25, I'm going to draw a line out at 30 degrees to the right and a line up at 30 degrees to the left. From the 2 points that I've drawn in, I'm just going to draw them vertically up. So from this one over to the right is going to go vertically up, and this one over here to the left is going to go vertically up as well. And from them points, I'm going to meet them. So they're going to meet at 30 degrees from that point and 30 degrees from this point. That's going to find the back of the shape. So it's going to be somewhere along this line, and find where along that line. I'm just going to go to this point and transfer that up at 30 degrees to the left, and that's going to find me the back point of the shape. Okay, so we can see the base now starting to make shape. First thing I want to do now is to make the cut into that, so the cut at 45 degrees. Now, I can't come along with my 45 degree set square anymore and put that down and draw a 45 degree line like that and hope that it's correct in isometric. It won't be. I have to find out how wide this angle is and how tall this angle is. So what I'm going to do is I'm going to draw a line down through that angle. Okay, height of that is 25, so it's going to be somewhere along this 25 mil line. And from this corner here to this corner here is going to be 25 mil as well, because it's a 45 degree line. So I need to measure in here 25 mil. To get this point, and I can join that point down to this corner here like this. Okay, I'm going with a firm line. I can transfer across like this and back down. Okay, so that's that cut surface now. And I can set send this back here. And this back here to get this front surface here as well. Okay, so I'm just taking it step by step. Next thing I want to do is to find this cut in the center here as well. Okay, so from the front of the shape, how far, or from this cut surface, say, okay, how far in does it go? So what's the distance between here and here? Okay, we find that in the plan as well, and we know that that is meant to be 15 mil. So measure in from that cut surface 15 mil and draw a construction line like this here. Okay, from that line, how far back does the cut go? So what's the distance between here and here? I'd go and I'd find this distance here. So from here to here. So sorry, what I'm actually trying to find here was this distance, and now I'm looking for this distance here. Okay, and I know that that is meant to be 65. Okay, so I can draw that in now as well. Okay, now I'm going to try to find this distance here, so from here to here. So that would be this distance here, from here to here, and I know that that's meant to be 15, so I can measure in here 15. This distance here is meant to be 50, so I can measure in 50. This distance here is meant to be 15, so I can measure in 15, and I'll be left over with 20. So that's this distance here. Okay, so this square here, or this rectangular shape, is the rectangle that's going to be cut out of my shape. So I need to cut into this shape here now as well. But as I said, it doesn't cut all the way into the shape. It only cuts 20 mil into it. Okay, so I'm going to firm in the rectangle first, just so we can see it clearly. Okay, and I'm going to draw a line vertically down from this corner here. Okay, so this is the corner that is going to cut into the shape. And as we said, this height here altogether is 25, but these dotted lines only go down 20 mil. So that's how we know it only cuts into that shape 20 mil. Okay, so that's now the cut taken out of it. And the last thing we want to draw now is this curved shape here. So I'm going to fill in this line. I'm going to fill in the front of that curve. This line here. Okay, we're ready now to put the curve on it. So what I'm going to do first is I'm going to pretend that this is a rectangle. Okay, so it's 80 wide and 40 tall. So I'm going to draw that in. Now this is 80 wide here already, but I'm just going to draw up 40 mil. So I usually just take things as being rectangular or square shaped at the start, and then once I have it drawn as a rectangle, I can start thinking about, okay, well, there's this cut being taken out of it and there's this hole being cut into it. Okay, try to take it just as a box first and then cut it away. And always start with a construction line, and once you're 100% sure, then you can go over it with a firm line. Okay, so that's the rectangular shape now that this curve is going to fit into, and I'm going to work on the front face here first. Okay, so we're going to split up this circle using the 30-60 method. So that's the 30-60 set square. So the set square that we've been using already, I'm going to lay it at 30 degrees to the left, so 30 degrees in this direction. Go to the center point of this circle and just draw a line out like that to the circumference. 30 degrees to the right, 60 degrees to the left, and 60 degrees to the right. Okay, and we'll find 7 points on that circle. So the first one is this one here, it's going to be called 0. Next one is this one, it's going to be called 1. Then 2. The top point is going to be 3, 4, 5, and 6. So I've called 1 0, so there's actually 7 points, but they're called 1 0 to 6. So there are points. What I'm going to do now is I'm going to drop them vertically down until they cut, I suppose, the diameter of that circle. So I'm going to drop them vertically down. Okay, because I want to get all these points along the same line. And I can label them down here. I can label them 0, 1, 2, 3, 4, 5. And if you look, 0 and 6 are actually still on that line. So they're always on that line. Okay, and what that line represents there is this line here. Okay, so this line here represents this line here. And what I want to do now is transfer these measurements over to that line. So if I go and I measure that line, it is 80 long, find halfway is 40, and you'll find that that gives me point number 3. All the way to the left gives me point number 0, so all the way to the left is going to give me point number 0, and all the way to the right is going to give me point number 6. To find 0.45 and 2 and 1, I'm going to grab my compass and I'm going to set it at 3. So the sharp point's at 3, and I'm going to open my compass to number 2. Okay, and that distance now is going to be brought over to number 3 here, and that is going to give me number 2 to the left. And if you see here, number 3 and number 4 are the same distance apart as number 3 and number 2. So you can keep that measurement and bring it over here to get number 3, or sorry, to get number 2 and number 4. So I've got number 2 and I've got number 4. The next one I want to get is 1 and 5, so I'm going to 3. I'm opening it up to 1, just like I did before. And I'm going to flip it over here and you'll see that it's the same as 6 as well. And I can go back to 3 over here, and I can go, number 1 is going to be here, and number 5 is going to be here. 1 and 5. Okay, now before we brought all them points down, there was only 2 points on that line. So 0 and 6 were the only 2 points on that line. That means that all the rest of them have to be shot back up. So remember, we brought all these down, we now have to bring them back up. the same distance as what they've been brought down. Okay, so 3 is an easy one. We know if this goes straight up to the top of the shape. So I can actually just put number 3 straight up. Okay, and that will find me number 3 here. Okay, all of the rest of them have to be brought vertically up as well, so I'm just going to send a vertical line from 4 straight up, number 5 straight up, number 2 straight up, and number 1 straight up. Okay, but we don't know how far they go up. To find how far they go up, we have to go to the actual number. So number 1. I'm going to go to number 1 on the line and open it until I get to number 1. So taking the height that we dropped it down, so we dropped it down this height, now we need to bring it back up so it goes up the same height. So taking this height, bringing it over to number 1 over here and marking it on the line. Okay, so that's where number 1 is going to be. So I can actually mark that now and I can call that number 1, and that's where it's going to finish up. If we have number 1's height, it's going to be the same as number 5's height. So that's a nice trick to know, is that number 1 and number 5 are going to be the same height. And if that's the case, number 4 and number 2 are going to be the same height as well. So I can go to number 4 and number 2. And I can call that number 2 and I can call that number 4. Okay, so I have now points along my curve. I've taken all these points, I brought them over, and I've shown these points on this curve, onto my isometric. So what I can do now is very lightly go over it and try to form a nice curve. So we'll see now, by the way that that curve has come out, that a compass wouldn't have drawn this curve for us. Okay, because of the way we're looking at it, the curve comes out looking very different to what a compass would produce. Okay, we get a nice curve like that. Okay, only problem is now that we want to have the same arc going on the back of the shape. So what I'm going to do from point 5, 4, 3, 2 and 1, I'm going to draw a line out to the right with a 30-degree angle. So with my set square, line out here to the right, number 2 out to the right, number 3, and these are just construction lines, guys, 4, 5 and 6. Okay, so if we're looking at that arc, okay, so this semicircle even, from the plan and even in the end view, we'll see that it is always going to be 20 mil wide. Okay, so from the front to the back is always 20 mil. So with that knowledge, we can set our compass to 20 mil. So I'm just setting it off this measurement here, and I can go to number 5 and I can project that point back 20 mil. Okay, so from here to here now is 20 mil. From 4 back is going to be 20 mil. From 3 back is going to be 20 mil. From 2 back is going to be 20 mil, and from 1 back is going to be 20 mil. Okay, and again, I'm going to label them. So this now is my new 0.5, this is my new 0.6, my new 0.4, 3, 2, and 1. And with them points now, I can lightly again go over this with an arc, a nice curve, and once we have a nice curve, we can go over it with a firm line. create a shape like that. So we now have our object drawn in orthographic, we have a freehand sketch drawn, and we have our isometric drawn. The last thing we want to do is to model it, so a 3D model, and we'll do that using Onshape.